Welcome, everyone. I'm Jill Schaefer, and I'm here with Todd Katzner. We work for the US Geological Survey, and we are organizing this lecture series on wind-wildlife interactions. Before we introduce today's speaker, Todd and I would like to thank all of you for joining us. And we would also like to support the organizations that have supported this lecture series. That includes the US Embassy in Astana that proposed this idea, the organization that is hosting today's Zoom, ACBK, and the US Geological Survey that has allowed Todd and I the time to do this project. Chevron has donated the monies for translation services for this lecture series, and we thank them. We also like to thank our speakers who have agreed to share with you their expertise on various topics. Just as a reminder of what this lecture series, the purpose of it is, it's designed to review the background information, concepts, and techniques that reflect the state of the art in the science, mitigation, and policy regarding wind-wildlife interactions in the United States of America. As wind energy grows in Central Asia and beyond, these issues are of growing importance. Our goal in these lectures is to provide a basic background on the study and assessment of wind-wildlife interactions, and to provide you, our participants, an understanding of the tools used for those assessments. Please note that we are providing the literature sources that we talk about in each of the lectures so that you can do your own reading on the background information and also have that information readily at hand for future reference. All of these resources, including the pre-lecture reading, the post-lecture list of sources, and the actual recorded lectures themselves, are available on the ACBK website, which Yenlik, you could put your link out to the ACBK website on the chat, but I believe most of the participants had to register through that portal anyway. The 7 themes of our lectures are pre-construction surveys for birds, pre-construction surveys for bats, post-construction surveys for all taxa, estimating detection rates, mitigation approaches, regulatory and policy considerations, and best management practices to ameliorate any negative wind-wildlife interactions. Todd and I introduced this lecture series back in September and in Astana and Almaty, and this is a continuation. I believe we're on about lecture number 4 in terms of the virtual components, and we are thrilled to present today's lecture. So Todd, would you be so kind as to introduce our speaker?
Absolutely. Our speaker today is Tara Conkling, and Tara is a wildlife biologist with USGS, the US Geological Survey, which is also my organization. She works from the Snake River Field Station in Boise, Idaho, but she's actually stationed in Davis, California. Tara has more than 15 years of experience focusing on applied ecological research, addressing factors such as renewable energy, human-wildlife interactions, behavioral ecology, and general avian ecology. Importantly, for this presentation, she has for several years, about 6 or 8 years, been a member of the Alameda County Technical Advisory Committee for the Altamont Pass Wind Resource Area. Tara has her bachelor's degree from Kansas State University, and then her master's from Texas A&M University, and her PhD from Mississippi State University. Her master's and her PhD focused on aspects of avian ecology related to human-wildlife interactions. So before I turn it over to Tara, I just want to remind everybody that You should feel free to ask questions at the end of the presentations. You are welcome to write questions in the chat. If questions are written in Russian or Kazakh, they can be translated, so don't be shy. And then you can also raise your virtual hand if you want to actually speak a question. And then the last thing, and we will remind you about this at the end, we are trying to do a survey on a regular basis so that Jill and I can understand how we can make this lecture series more useful to you. So please, at the end of this, fill out the survey, let us know what we can do better. So without further ado, Tara, do you want to take it away and try and share screens?
Yes, let's see if Zoom cooperates this morning, or this evening, I suppose I should say. Let's see. That
looks good.
working? Okay, awesome. Well, good morning, or I guess it is evening over where most everyone else is. As Todd said, I'm Tara Conkling, and I'm here today to talk a bit about post-construction fatality monitoring at wind energy facilities, looking at both birds and bats. If my screen's a little bit, so here we go. So renewable energy, as we all know, has been growing in recent years to help us meet renewable energy portfolios, reduce our dependencies on fossil fuels, help with climate change. But for all of its benefits, it can still have some negative impacts on wildlife species. These can include habitat loss and fragmentation, especially when building or maintaining facilities. They can also serve as a direct source of fatalities. This happens a lot at wind facilities, particularly when they collide with the turbine blades. So we can get a good understanding of what's going on in terms of fatality monitoring at the local facilities to help us gain a better understanding of the species that are being impacted by these deaths, not only the number of species, but also how many individuals may be being killed, and if this might potentially have population level impacts. Compiling all this information is important to help us answer these questions. So with monitoring at wind facilities, there's monitoring that happens at a number of different stages. As there's been a previous topic, looking at pre-construction surveys. A lot of these surveys are designed to help determine what wildlife populations are in an area and how they may be potentially affected by the development of that wind farm. These can include a variety of different survey methods, such as acoustic surveys for birds and bats, breeding surveys, especially if raptors are concerned, looking for breeding birds, migration counts, and even just looking at the literature review, looking through previous reports and data sets to get an idea of the species that may be impacted in a given area. Now, post-construction is looking specifically at what's happening at the site after the facility is operational. So these can include a number of different surveys as well. The most common one, and what we'll be talking about later, is carcass searches. So looking for dead birds and bats on the ground, as well as many other survey types, such as behavioral observations, how birds or bats are flying around and interacting.
Как птицы и летучие мыши взаимодействуют с турбинами, подсчеты. Это все помогает нам понять, какова смертность этих особей после строительства. И в идеальном мире можно использовать данные всех этих методов для того, чтобы ответить на исследовательский вопрос о воздействии объекта до и после. Особенно если вы собираете данные и до, и после. потому что это действительно очень полезно, чтобы провести мета-анализ, чтобы понять, как эти объекты влияют на популяции.
But for the purpose of this talk, we're going to focus specifically on these carcass searches here in that post-construction phase. Many of the factors to consider when setting them up, and then kind of where we go from there. The carcass searches, the main goal of these surveys is to estimate fatalities from these raw counts. Because when you're going out and looking for dead birds and bats on the ground, you're finding a number of carcasses out there. But the number of dead birds and bats that you find is an estimate of the actual deaths, because carcasses disappear. You may miss carcasses during your searches. Predators may remove the carcasses before you even have a chance to find them. You may be searching a smaller area than where they're falling. So there's many factors that can influence whether or not you're counting all the carcasses out there. And so there's 4 parts to consider when you're designing these carcass searches, thinking about not only what your overall objectives are in terms of what data you want to collect, what research questions to answer, the target species of what you're specifically looking for, and then some other inherent biases that can influence these results, and then detection probability, which allows you to correct for these carcasses that you may be not observing that are in the landscape. So for monitoring objectives, the main goal of this is to identify the species killed at facilities, or often to estimate the number of fatalities that are killed at a wind facility, because these numbers can help us inform mitigation. So it might be very useful, especially if a facility is in a novel environment where there haven't been many, say, a desert environment or grassland in your region, to just know what species are passing through the area and are likely impacted by dying at that facility. But it could also be really useful to understand how many of each of those species may be killed, especially if there's rare or threatened species of interest. If a really rare species has 1 or 2 birds that are killed, that might be less of a concern than if you realize that you're killing 50 to 100 of that rare species. Then that could be really useful for informing mitigation practices and using that data to help reduce those fatalities at that facility and broader. So these species can include either species of concern, especially if there are threatened and endangered species of a given area, and they can also include potentially site-specific or region-specific thresholds. For example, in Altamont Pass Wind Resource Area, which is in California on the west coast of the US, they have set fatality thresholds for 4 or 5 different focal species. For example, the golden eagle fatality threshold is set at 0.08 golden eagle deaths per installed megawatt. So this provides a baseline. So when you estimate how many birds are being killed, if the number of golden eagle deaths is greater than that number, then the particular wind farm has to undergo mitigation practices to reduce those fatalities. So that's an example of a site that's using a predetermined value that might not be addressing any scientific research questions, but is driven more on what the location is interested in. So your monitoring objectives can also help determine if there's any temporal or spatial patterns in fatalities. This is really useful if there is concern about changes in species populations over a number of years, especially if they're impacted by other factors such as droughts, high death years, low productivity. And it can also be useful, especially when setting up mitigation practices. for example, bats during fall migration. Many bat species here in the US experience really high levels of fatalities at wind farms, especially during fall migration periods when large numbers are passing through. And so if you understand and you can determine when these fatalities are happening, you can use mitigation appropriately, such as setting seasonal curtailments to reduce the wind turbines moving as much during these seasonal peaks of migration to reduce bat deaths. You can also set them to address specific research questions. As scientists, we love to have these questions answered, but oftentimes monitoring, at least in the US at wind facilities, is often more driven by specific project requirements, usually permit requirements that tell that you need to look for dead birds and bats for X number of years. And sometimes the studies are set up just to address those specific questions and maybe not as much collecting data to help kind of answer broader research questions, especially in terms of meta-analyses, where you can combine data not only from a single facility looking at spatial variation across turbines, but also looking at meta-analyses across multiple facilities or regions by being able to pool that data that's being collected. So answering standardized research questions across multiple sites can be really a useful approach to use that we don't necessarily use to the full strength that we can here in the US. And it can also help address cumulative or population scale impacts if you're collecting the type of data that can help answer those questions. But again, it's thinking of incorporating these specific research objectives into the monitoring strategies before the monitoring begins. So once you figure out what questions you want to look at and type of data you want to collect, then it's important to consider the species that you want to focus on for the monitoring periods. Now, these can include species of conservation interests, whether they be IUCN listed species or listed species at a national or regional level. In the US, a good example of this are golden eagles that are protected by a number of federal laws in this country. And so it's often important to specifically monitor golden eagle fatalities at wind turbines to understand how many deaths are occurring at fatality facilities and to help reduce those deaths and understand what's happening in the population as a whole, especially since they have a fairly limited population of, I think, around 60,000 birds in North America. Whereas other focal species might be of interest for a facility, but they may be fairly common. Red-tailed hawks have well over millions of individuals, but they also have a very high potential for collisions with wind turbines. They're one of the top 5 species of documented fatalities in the US in terms of being killed. So it might be really important to understand what's happening to this common species to help reduce deaths as well, because what helps reduce deaths for a species like red-tailed hawks or Mexican free-tailed bats, those are also a very common species killed in high numbers, might also be practices that can then be useful for less common species that are also at risk, other bat species, other raptors, etc. You can also focus on different size classes or species groups if that is what your particular site or project is interested in. These can include classifying, looking just at large birds or small birds, bats, raptors, songbirds, or even looking at all species. Now, this can have an impact on how you go about post-construction monitoring, because if you're focusing on all species, that means you need to have specific search intervals and search methods that can find the carcasses of very tiny birds and bats on the ground, such as hummingbirds, whereas a search for a large dead golden eagle is going to be quite different, and it's going to be much easier to find those eagles. You may need to search less frequently. So keeping in mind the species that are being monitored will very much drive how you survey. Now, some of the other sources of bias in this process can include study periods of when you're collecting the data. For example, there's often seasonal peaks in terms of
Часто
fatality.
бывают сезонные пики смертности на ветровых турбинах, особенно во время осенней и весенней миграции, когда большое количество птиц и летучих мышей пролетает по территории, тогда будет больше пострадавших особей. И если ваш мониторинг проводится только зимой, то вы не сможете записать пиковые значения и много данных потерять. И, соответственно, у вас будет неправильное понимание, у вас будут неверные данные подсчета, и у вас будет недооцененная смертность, потому что не учтены периоды с высокой смертностью. И поэтому нужно понимать, какие у вас местные виды, проводить мониторинг в нужное время для того, чтобы правильно оценить смертность. И зона поиска также может повлиять на то, как вы транслируете данные подсчета в показатели по смертности. Например, рельеф, особенно если есть какие-то зоны, которые тяжело обыскать, например, какие-то рифы, либо если там плотный растительный покров. По сравнению с покровом с небольшим количеством растительности. Бывает физически сложно найти, потому что трава высокая, то есть тушку не так легко заметить. Все это влияет на вашу возможность найти тушки. Также бывают тушки, которые вообще падают за пределами зоны поиска. Например, вокруг турбины вы ведете поиск, а иногда тушки могут упасть вообще далеко, и мы не думаем, что они там лежат, но они там, а вы их не подсчитали, и это опять же меняет ваши цифры. Пол и Робин на следующей неделе будут говорить о данной проблеме, как ее решить при помощи анализа. Опять же, есть погрешность, связанная с травмами, повреждениями. Например, птица повреждена, но она как-то может отползти и, скорее всего, умрет, но при этом вы не найдете ее в зоне поиска и не учтете. И сами турбины также могут повлиять на количество смертей, на подсчет количества смертей. Например, операционный статус турбины. Например, работающая турбина, конечно, больше смертности несет, чем та турбина, которая временно не работает, сломана. Соответственно, если турбина какое-то время простаивала, и, соответственно, у нас не будет точных данных о смертности, потому что мы, получается, тогда замерим количество тушек при одной, например, неработающей турбины. Теперь участок поиска тушек и проездные пути, трансекты.
That's available for surveying, or a lot of times it's also based on the fall distance based using a common ballistic model. So just using general physics of if a turbine is hitting a bird or bat, how far that carcass is likely to fly through the air before it lands on the ground. Now, a smaller bird or bat is going to fly very much less of a distance than a big, heavy carcass. And so these calculations are based mostly on body size, but they're also assuming a very flat ground So it's not a turbine on a hill with the carcass may roll down a hill. It's not accounting for factors like wind that may blow a carcass further out. But in a sense, a lot of these survey size areas that have been used traditionally in the US are based on these simplistic ballistic models. So for bats, for example, on the right side of the screen, it estimates that bat carcasses, even for large modern scale turbines up to that 100, 150 meters in height, should be falling no more than 80 meters outside the area. So if you're searching an area bigger than that, you should, in theory, be finding all the carcasses. Now we find that that's often not the case, but you can correct for that search area where you're looking versus where the carcasses are falling. Now, in general, these are some recommendations based on historic data use. Again, these are at least 10 years old, but oftentimes the recommendations for searching for bats, the transect or the survey area width was at least half the turbine height to the ground. So that's accounting for total turbine height from the top tip of the blade to the ground, whereas they suggested a bird survey area of twice the turbine height. Now, in practice, survey areas tend to be more representative of that distance for bats rather than the fall distance for birds. So we might be kind of underestimating our survey areas a bit, because what happens if bats fall farther than that distance? Well, you can correct for some of these using value that Paul will talk a bit more about in his presentation in a couple weeks. But density weighted proportion is the proportion of area searched where the carcasses are likely to fall. So it accounts for that whole area around the turbine and that whole area where those carcasses are going to land on the ground. And you can use how much area that you're searching within that full circle to account for carcasses you may have missed. So this might be, if you're searching a smaller circle around a turbine, then where those carcasses are going to fall. Or if there's areas within your search area, so in the figure down here in this yellow area here, if there's a cliff face in the bottom half that you can't search, or there's some really dense vegetation that you can't search, you can also account for that area that you missed in the surveys. This can be used. Sometimes people survey for bats using only looking for bats on roads and pads around the turbines themselves. So that's accounting for you're only searching a small proportion of that area where those bats are likely to fall. So your density weighted proportion would be much less than 1.0, where 1 is you're searching everywhere they may fall. Now, in the case of bats, we find that sometimes they're falling much farther than we think they are. This plot down here is some raw carcass data from a turbine monitored in Altamont Pass in California. And so all those dots there are various different bat species and where they fell. Now, this circle is over 120 meters in diameter, or not diameter, in radius, which means that we would be expecting, based on that ballistic model, that there shouldn't be any bat carcasses past this middle point here. But clearly, there are a lot of bats here, and we don't know what would have fallen outside this point because the searchers only searched within this area here. So, but we can account for the bats that may be out here and birds that we may have missed by setting that density weighted proportion.
И поэтому мы устанавливаем взвешенную по плотностью доли меньше, чем 1. На разных формах это работает. Опять же, в зависимости от того, как расположена турбина на ландшафте. И конструкция турбины влияет на характер падения тушки. И обычно падают по ветру тушки. Это в Южной Калифорнии. Особенно старые турбины, они стояли очень близко друг к другу. И, соответственно, нужно искать вот в таком ландшафте по методу прямоугольника, потому что турбины так близко друг к другу, что если птица умрет от этой турбины, она, скорее всего, упадет вот где-то рядом с соседней турбиной. Соответственно, нужно менять свою структуру исследования.
You can often do circular search areas around those. The size of that is again determined by how big that turbine is, because the height of that turbine is going to determine how far it can throw carcasses that hit those blades. And the blade length can also be important. A turbine that's 150 meters tall but has 50-meter long blades is going to potentially throw carcasses a different distance than one that's with 80-meter blade length, but just a shorter hub height, just due to physics and the length of that fulcrum for launching those birds. So accounting for the turbine in terms of setting how wide of a search area you need to cover is important. And then determining the search pattern within that search area is going to be very much dependent on the size of species that you're looking for. If you're searching for small birds and bats, the density of your survey transects is going to be much closer, maybe 5 to 10 meters apart, than searching for a large carcass like a golden eagle on the landscape. You might be able to kind of space your survey transects a little bit further apart because you're searching for a much bigger object on the ground. Now, in terms of how many to search, that again varies based on the size of your facility. You want to collect enough data so you have a reasonably good idea of what's going on in the landscape. So if there's a small facility, it's generally recommended that if you have 10 or less turbines, it's just easy enough to sample all of them in a regular manner. However, you have a lot more turbines than that, say 50, 100, 200 turbines, then you're not going to be able to efficiently cover all of those in any reasonable amount of time. So you'll need to randomly select some turbines to monitor. It could be a subset of each turbine monitored for 1 year, for multiple years, but using some kind of probabilistic sampling approach for selecting those, using random sampling to ensure that your sample is representative of what's going on at the site as a whole. And if you have drastically different habitat types, especially within a facility, it would be really useful to stratify those turbines that you're selecting by those habitat types. But this practice is not commonly done, and it's usually assumed that everything is the same across the sites, which may or may not be an accurate assumption. Now, in terms of where you're searching in the landscape, again, those transects vary a lot, not only based on the species that you're looking for, but also the terrain. If you're dealing with really difficult terrain, you may have to space your transects accordingly. As some sites, they do concentric rings around turbines. You just go in a larger and larger circle looking around. This can be useful in some sites, and other times it can be pretty difficult because you're spending all your time looking at that center turbine to figure out how far you are out. And so a lot of studies that we've done, we've just had a systematic grid put out in the landscape. So then you're just heading in a north-south direction, back and forth across the grid. But you may still end up with areas that you're not able to search due to terrain. In this picture, it's a very small cliff drainage, but in some cases you can have really steep rocky cliffs that you can't necessarily search over. And so those are just some factors to keep in mind, that there may be areas within the fall area that you want to search that you just have to exclude due to hazards such as terrain, roads, or other factors. And again, bigger plots, the more area you search around a turbine, the more carcasses you're going to find, especially if you're searching out far enough to make sure that you're covering that entire ground where the birds and bats can fall. So finding more carcasses then can help you also increase your detection probability in terms of you're finding more birds and bats. So you can then generate more precise fatality estimates to have a better idea of what's happening at your facility. But that also requires a balance because you are doing more effort per search. If you have a rectangular search area, extending your searches on either side, you're adding a little bit area here, so it's not adding as much. But if you're doing a full circular search for every 10 meters, you're expanding that search area, you're increasing your total search area pretty substantially. So it's finding that nice balance between searching a large enough area that you feel you're able to adequately find the carcasses that you're looking for, but not spending all your time searching in the landscape for carcasses that may not be out there, because you can use the estimating programs, like GenEst, to help correct for some of that. So in terms of seasons or search frequencies, I mentioned season a little bit earlier. It's especially depending on the species that you're looking for. It may be really important to have year-round searches, especially for multiple years, to get an idea of when seasonal peaks of fatalities occur, especially if there's interest in reducing fatalities during those high kill times, such as fall migrations. But sometimes there may be some focal species where you're only looking at migration periods. So you may only be doing those surveys or concentrating efforts on those surveys during those fatality peaks. Or maybe there's areas that are inaccessible during certain seasons, such as winter, when there may be lots of snow on the ground, very few fatalities. It may be not worth the time and effort to look for fatalities there if you can concentrate your efforts on when you're more likely to find carcasses, and then using mitigation practices during those times to better reduce fatalities. But in terms of search frequencies, this can also change quite a bit depending on what species you're focused on. You'll need shorter time between visits, especially if you're including smaller birds in your monitoring, just because the smaller birds tend to disappear quite quickly off the landscape. Predators carry them off. And so it can be really challenging to schedule a visit within a period of time where you're going to find that dead bird on the ground. Whereas larger birds create larger carcasses that may stay longer in the landscape, even if not as whole carcasses. Finding bits and pieces and feather spots, you may be much more likely to find pieces of a larger bird, because it's going to be more challenging for a predator to carry off that entire carcass, such as the screeb here in this picture. So some of the most common search patterns for fatality searches can range from as frequently as every day to a couple times a week, once a week, even monthly or bi-monthly. Now, the bi-monthly surveys were used historically. They're not used very much now, just because you miss a lot of data there's a lot of carcasses that disappear, and those estimates are not really that useful in terms of monitoring. So the more common used ones are usually the 3 days to 7 days to 14 days. So doing surveys twice a month out in the landscape. Now it is that time cost balance for search effort versus the potential for missing carcasses. So in this figure down here, we have a couple of different example carcasses that may be in the landscape. Now, if we're doing searches every 14 days, we may be able to find this dead bird on the ground by that 14-day search. But this one we miss because a predator comes along and removes it before we have a chance to even go out there and find it in the landscape. So sometimes searching more frequently, like on a weekly basis, allows you to be able to find more carcasses before they're removed, get a better idea of that detection probability, and get a better idea of how many fatalities may be happening in that landscape, especially if we're looking for those smaller birds and bats that can be quite challenging to find. In terms of survey duration, it's often recommended to do at least 1 year, but multiple years of data is always much better for identifying temporal patterns. But sometimes that length is often determined by regulations or permit requirements. Usually if a permit says do 1 year monitoring, the facility may only monitor for that 1 year. But again, as we know in science, more years help us get more data helps us better answer our questions. So having multiple seasons or year-round surveys and multiple years of data, if you can afford to do so, it's always more useful to help capture those changes in fatalities between years. So detection probability is also that important factor to consider. It's a combination of searcher efficiency, so how well those searchers can find those dead carcasses on the landscape, and how long they stay out there for us to find before scavengers remove them. And it includes a number of different factors that all combine together. And this will all make much more sense when Paul includes it in his discussion about GenEst. But detection probability allows us to correct for the carcasses that we don't find out in the landscape. So we know how many we do find, but since we miss some, combining with searcher efficiency, so the ones that we're missing that are out there, the ones that are removed by the predators so they don't persist in the landscape, and then also accounting for how many turbines we're surveying. If we're only looking at 2 of the 10 turbines out there, then obviously our raw numbers are based on a small subset of turbines, and we have to expand that to estimate how many fatalities would be occurring at the whole facility. And then of course, accounting for that area that we're searching or not searching where the carcasses may be falling. And so this just has a quick definitions of all of these different terms again. So searcher efficiency is just how many we found, carcass persistence, how long do they last out there, and then combined with how many of the total turbines we're searching, and then the unsearchable areas that we are not including in our searches. For searcher efficiency, it can vary quite a bit by the size of the carcass and the vegetation. So in this picture here, this is a red-tailed hawk found at one of the turbine sites. So when you're searching for a big bird in a very open landscape, it can be really easy to find that carcass, and that searcher efficiency is really close to 1, which means you're finding everything out there. However, this can vary quite a bit when we change the landscape. and we change the size of what we're looking for. So if you look closely at this picture, there is a dead bat on the ground in this picture. If anyone can't find it, this is a really good example of why searcher efficiency for bats can be quite low, especially for humans. In some cases, it being less than 5%. The bat is somewhere within this circle, I promise. Here's a nice close-up. So this is what a free-tailed bat can look like on the ground. This is a trail carcass, but that just shows how difficult it can be to find some of these out in the landscape. Now, dogs can find much more.
Да лучше ищут собаки. Гораздо больше тушек находят, чем люди. Они их находят, и у собак гораздо больше эффективность учетчика, особенно когда они ищут маленьких птиц и летучих мышей. И обычно это хорошо обученные собаки. Это не просто чья-то собака, которая гуляет. Нужно обучить таких собак, и они очень полезны. Если можно их включить в мониторинг, это очень хорошо. Сохранность тушек, как долго сохраняется тушка на ландшафте. И когда идет туда учетчик, до сих пор ли тушка сохраняется там? И можно оценить сохранность учетчика, разместив так называемые исследуемые или пробные тушки. И затем приходить регулярно, чтобы понять, как долго находится там тушка. И когда она исчезнет, посмотреть. И когда такие исследования с пробными тушками проводятся, эти данные помогают вам расширить.
So these trial carcasses can be distributed across time and turbines. You do need to make sure that you have sufficient samples across different size classes, sort of small, sometimes medium and large birds, having separate carcasses for bats. And you may also need to put additional carcasses out there if you have a lot of variation in vegetation types, or if you suspect that the predator situation may change quite a bit across seasons. If there's periods where predators may be much more likely to remove carcasses from the landscape, or if vegetation may be more likely to hide carcasses, say during growing season when grass may get really tall, they can hide carcasses that searchers may miss. So this was just kind of a brief overview of many different factors to consider when constructing, post-construction monitoring. There's a lot more details in terms of if you have a site, determining what specific search intervals or areas to cover. And then you can also use all of this to estimate your true number of fatalities. So you're taking your numbers found on your surveys and accounting for that number missed, using those detection probability estimates with those searcher efficiency, carcass persistence, and other factors. And you can do all this with computer software nowadays. GenEst is a freely available program that's easy to use, and it will be the topic of the next lecture series. Paul Raby will be talking all about GenEst, and I believe using some sample data to walk through the entire process of analyzing data, I hope. And with that, I guess we'll take any questions. Thank you very much for taking the time out of your busy days to attend these lectures. It's much appreciated.
Thank you, Tara. That was fantastic. Yenli, can we also unmute Jill? Yeah, that's perfect. We've had a number of questions in the chat, and I think we should go back all the way to the first one, if possible. Alexandra asked if post-construction monitoring is mandatory in a preliminary environmental assessment. And specifically, she meant collecting data on bird deaths before construction and after construction.
That is a great question. And no, it is not, but it would be really useful if it was, because that would help address, I know that background mortality is a term that people like to bring up a lot in terms of whether or not the birds and bats you're finding on the ground are just, they're already dead in the landscape and not necessarily dying because of the turbine blades. But usually there's not anybody going out and looking for dead birds and bats and fatalities in that pre-construction stage. I think we've done a literature review looking for that type of data, and I think it occurred in maybe less than 2% of any of the reports that we looked at where sites were specifically collecting that data beforehand. But it'd be really great if they did, because then that would account for that and kind of give you a very nice before after comparison.
So Pia wrote a question in the chat, but also has her hand up. So, and Paul Raby answered the question in the chat. Pia, if your question is more of the same, maybe repeat the question in the, okay, well, let me repeat the question and the answer and then give you a chance. Pia asked if the speed of the blade affects the fall distance for the carcass. And Paul from West, who will be our speaker next week, answered very clearly, which the basic answer is yes. The speed of the blade does have an impact. The size of the blade has an impact. The direction of the wind has an impact, and the speed of the wind. So all of these things can impact how a carcass falls to the ground. Pia, do you want to ask your question next? And then we have two other questions in the chat.
Yes, of course. First, I would like to thank Tara for having this presentation. It was very interesting. I've been keeping track of all the research that's been going on in regards to wind energy and bird fatalities. So my question is related also for the post-construction monitoring, but more in terms of avoidance behavior in relation to the indirect habitat loss. So today we've been talking about the carcass monitoring, but now I'm wondering, have you done any telemetry studies on the breeding pairs of the golden eagle there in the Altamont area? And if you did, have you noticed any indirect habitat loss to those pairs?
I have not been involved with any of the telemetry monitoring for those golden eagles. There are a couple of researchers that have been putting telemetry units on golden eagles in that area and been kind of looking at use. I don't know how much they've specifically addressed in terms of like avoidance or behaviors in that regard, especially at that site. But I know Todd may have more familiarity in terms of eagle telemetry at wind facilities and what's been monitored.
I think with regard to habitat loss, there have not been good studies showing behavioral changes for eagles. We do know on migration, eagles will, if they see a wind turbine, they will make a detour. They will change their flight to avoid it. But we don't have similar data from telemetry or from territorial golden eagles. So Tara, there's the next question in the chat is, do you have any recommendations in terms of literature regarding hub plus blade length and detection area calculations? I think that's search area calculations.
I don't know offhand, but that may be a really great question for Paul, if not for now, for in 2 weeks, because he's probably much more familiar with the statistical side and those physics equations in terms of the best search areas for doing based on those turbine dimensions.
Okay. The next question, is it possible to map concentric detection belts for bats and then small birds and then large birds? So do you see patterns in fall distances based on size? And then what proportion of birds, of large birds, are wounded and are able to walk or fly away and later die?
As far as the second question for the crippling bias, I'm not sure if anyone has a known specific answer other than it's usually pretty small.
Обычно довольно мало такой погрешности, но она происходит. Мы не можем предполагать, что все птицы упали на той расстоянии, которое мы определили, потому что беркуты, например, получают травмы от лопасти, но они еще так улетают, либо проползают большие расстояния, и их мы не находим при поиске. Но я не знаю, сколько таких птиц. Говоря о расстоянии падения, да, возможно проанализировать данные падения, например, плотность летучих мышей и птиц на расстоянии от турбины. Это уже статистический вопрос. Нужно спросить Пола через пару недель. Я уверена, что он может это объяснить. Как рассчитывать расстояние падения и какой долю летушек можно найти и как интерпретировать эти цифры. Перед тем, как прочитать следующий вопрос, Пол сделал комментарий.
Practice handbook on post-construction monitoring and has some information on turbine sizes and search areas. And we put that in the chat, I think, at the last presentation, and we can put that information I think it's on the ACBK webpage as well, but we can provide people the links to that if they're interested.
Yeah, and that one is also listed in the list of papers for the lecture this week as well.
Okay, so it's in the literature cited for that Tara put on the ACBK webpage. Next question. Are there reports of increases in the number of fatalities of avian scavengers and raptors that might be due to attraction, birds being drawn in to the facility to scavenge on dead animals?
It depends. I think for the most part, a lot of the species killed at wind facilities, at least in more recent years, have usually been just kind of species occurring in the landscape. I don't know if some of these species might be coming in because of other dead birds and bats on the ground, but they're usually not scavenger species in terms of there's not increases of, say, vultures dying at the landscape. At some solar facilities, there's more instances of species being detected, not necessarily killed at the sites, but just being present in larger numbers, like common ravens coming in because of the facility being built, And in some of the older generation turbines, there was a lot of higher number of introduced species that are more common with people around, like rock pigeons or species like that. But those numbers have kind of decreased in recent years as they've switched to the bigger, more modern new generation turbines. And so we're not quite sure why there's fewer non-native kind of more scavenger species around at some of these wind facilities. But in terms of, yeah, just attracting them in there, it doesn't necessarily be the case. Or if they're being attracted, they're not necessarily being killed when they're attracted to this increased potential prey base. This as far as I.
That's, yeah. Another question, and by the way, we have now reached the end of the hour. I think Tara and I know Jill has to leave. Tara and I can stay for a little while longer, at least, and answer questions, but we understand if people have to go. The next question on the methods are, I guess, Raymond, I don't completely understand your question. Are such approaches possible for environmental impact assessment? How can they be applied in terms of temporal scale variations? Yenli, could you unmute Raymond maybe? Or to clarify, or you can write if you prefer.
Good morning or good afternoon. Consideration of methods. First of all, this appears to be an expensive studies. If you are to, or just on one taxa, or because if you are looking at maybe birds and bats in themselves and looking at investment alone, it will turn up to be an expensive study if you are considering integrating it in environmental impact assessment. And now, when you are going to look at the impacts themselves on those taxas, you can see that the risk is higher, highly rated than what you would have invested in. Now, the problem is on the, if you're going to do such a study and integrating it in impact assessment itself, would this be acceptable for most of the maybe investors? Or is it something that you could recommend, Tara, that for the financials, for example, African Development Bank, World Bank, IFC, that this is a good method, and if you're going to do it, it's very expensive, and in the time of planning
И во время плана проектов вы можете рекомендовать данный метод для проектов, потому что требуются данные для принятия решений. И многие страны этим не занимаются. Например, в Африке будет сложно проводить такие исследования с такими методами. По вариации, насколько я понял, есть ландшафтная вариация. И, соответственно, это еще больше удорожает такое исследование. Можете дать рекомендацию для
and then do it. Of course, we have institutions which are working with BirdLife International, IUCN, they are willing to take it up. But you see, on a baseline level, I am wondering how this is possible to be acceptable.
Those are all very good points. And yeah, within USGS, luckily, we don't have to deal with trying to balance all those costs. We just provide the science and leave other organizations to make those policy recommendations. But yes, it is an expensive process. But I'm sure that there's probably entities or parties out there that can help kind of balance, and especially if there's key focal species or species of interest, kind of tailoring the survey efforts to focus on those particular ones, so you can kind of maximize the amount of data and information that we can collected in a very cost efficient manner, to kind of get the most value out of any dollars being spent, because monitoring just for monitoring's sake could also be really expensive and not a great use of funds. But I'm sure that there's organizations out there that can help kind of balance with that. Todd, you have something to add?
Yeah, one thing that we have recently learned is that a lot of the international financing organizations now require environmental impact assessment with these types of surveys. And so USGS we are working with a few people to help design surveys, but we also hear of many others. I know that there are some large wind and solar projects planned for Kazakhstan and Uzbekistan. And in each case, there are environmental impact assessments that are part of the funding, the financing required. So I think, Raymond, one answer to your question is to encourage the banks to require this, because if the banks require it, then it will get done. There's another question in the chat. What is the threshold of the number of feathers found to consider a fatality, or blood or tissue? What if you only find one feather? And that especially becomes a problem with dogs, because they can find such small things.
Yeah, that's a great question as well. In terms of what usually counts as a carcass out in the landscape, they usually do a feather spot is at least usually 10 feathers, or body parts that are consistent with that the bird or bat's probably dead. So like if you're finding a wing fragment out there in the landscape, chances are the bird's probably not flopping around without that wing on there. So you can usually assume that that's a carcass. Now it gets a little more tricky, like Todd talked about, in terms of dogs, because dogs are really great on hitting on carcasses or hitting on feathers. Even if it's a feather patch here and a feather patch over here that might potentially be coming from the same carcass that's just kind of been torn apart in the landscape and found even on multiple visits. So it can be sometimes a challenge to determine whether or not you're finding new carcasses or not, or whether they're just feather piles or bits and pieces from previously found carcasses. So if you're finding body parts, you can usually kind of do a better comparison, seeing if you have a left leg and a right leg, things like that. But sometimes it's kind of just a using of a best guesstimate in terms of that this is likely the same carcass or a different carcass, and just acknowledging that that might be one of the places where you might be overestimating the number of carcasses you're finding out there if you're counting multiple feather spots as the same bird. But in terms of numbers, yeah, it's usually at least 10 feathers in a pile together to count as a carcass.
There is, I just put a link in the chat to the Good Practice Handbook. Aliona offered to translate the question in Russian in the chat. Aliona, are you unmuted? And
yes, we had one question in the chat, which was in what time of the day the most golden eagle fatalities are happening?
I'm not sure anybody really knows as to when they're actually getting hit, because usually they're just finding them either, sometimes after, if you're finding the actual live injured bird, usually it's within a few hours, but sometimes you're finding them days or weeks afterwards. And unless there's camera footage or telemetry units on the birds, then you won't know exactly when they're being killed. I know that there have been a few telemetry birds that have been killed at facilities, but I don't know offhand in terms of when those birds would have been killed. But that would be an instance where some of that data might be available.
Yeah. One thing to understand is that in the USA, most searches for golden eagles happen every 30 days, once per month. And so it's very difficult to know what time, even what day a bird died when you only search once a month. But Pia in the chat noted that there are not established post-construction monitoring in her country, and I think that is fairly typical for most countries, including the USA. Ohad, you have a question, and then there will be at least one more in the chat.
Hi, Todd. Thank you. I want to continue on my previous question that Tara answered. In a document, a technical report of the American Wind Wildlife Institute, it was from 2019, considered two feathers or a feather spot as a fatality from the turbine. To answer this, and we had long arguments with one of the participants here about how to interpret such a case. What we do searches, we call control searches near the turbines in the same environment, and then we compare if there are single feathers in this area, and then we deduct it from our calculations. And I must say that
Это из своих расчетов. У нас много единичных перьев. Мы видим, что это точно от турбины погибла птица, потому что перо разрезано. Мы в разных случаях по-разному подходим. Если это вид, который не летает обычно в этот сезон, то есть непонятно, охота была на эту птицу или она умерла от турбины. Если это не время для охоты, то, скорее всего, турбина умерла. И у нас есть здесь участник, который с собакой работает. И собака нашла чуть ли не через год тушку. То есть, сложно интерпретировать такие перья.
There is another question in the chat. Do you remove the carcass each time, a trial carcass, so that, or even a carcass you find, so that you don't find it again the next day or the next time you are monitoring?
That is, again, very much dependent on a site-by-site basis. For some species, you need to get approval for even picking up the carcasses, such as golden eagles. If a search team finds a golden eagle, they have to call in a person from Fish and Wildlife Service to come in and see the carcass on the ground and often collect the carcass themselves. And in some other cases, if the company or consultant monitoring, at least in the US, they have to have permits to salvage the carcasses on the ground. So if they don't have those permits, then they're not going to be picking up those carcasses in the first place. But you can account for those, and you can pick those up, or you have your search teams going out and documenting that you know that you had this carcass out there before, and picking up or leaving it on the landscape. And then sometimes it also may be that sometimes carcasses get left out there, even if they're found, because they might be part of some of those other trials, like those carcass persistence trials, where you're leaving carcasses out on the landscape to see how long they're going to stay out there. Now, those can get kind of tricky, especially when you're using things like dog teams, because the dogs do have a memory and they do tend to know that when they've hit a carcass in a certain area, they like to go back to that certain area to find bits and pieces again, because they get rewarded for finding things. So sometimes you might have to adapt in terms of putting those trial carcasses in a similar landscape, but not necessarily within your search area, to avoid having those dogs keep finding things all the time.
Okay. One more question in the chat, and then a hand is raised. Are there technologies in development for sensors that can detect when a blade collides with an animal?
Yeah, I believe that there are. I'm not sure like how fully developed or deployable they are, or how sensitive they are in terms of, can it tell if a giant blade is getting struck by a golden eagle versus a bat, because being able to distinguish between those might be really important. But they do have sensors that can detect when blades are getting hit. I know that they've tested some of this technology by, I think, launching tennis balls at turbine blades. But in terms of whether or not it's like ready for like full-time deployment, or how much it would even cost for deploying at facility, I don't really know answers to that.
For those of you who are interested, most of those technologies are accelerometers. It's very simple. The same accelerometer that's in your phone, you can put one on one end of the blade, the other on the other end, and the accelerometer can measure the vibrations, and the difference in the time that it is sensed can tell you where on the blade it was struck, and also how big, and all that stuff. Let's have Pia's question and maybe make that the last one for the day. Pia, do you want to go ahead?
Yes, thank you. If it's not related to this presentation, please stop me. But I heard that there's a dog expert here, so I have a question, because I'm also training my dog for searching. So I have a question related to the age and the overall status of the carcass. And I was wondering have you noticed any difference if the carcass is dry or fresh, or in any very decomposed? Have you noticed any difference in the overall detection rate of the dogs?
На обнаружение.
I think it's fine. Actually, it's probably a good question. I do know
Это хороший вопрос. Я знаю, что собаки в США, они реагируют на запах разлагающейся тушки. И не всегда они находят тушку, особенно если это свежая тушка. Специалист по собакам, вы можете поднять руку. Мы дадим вам слово на короткий ответ. А затем уже по имейлу будем общаться. И Пиа, вы отправьте свой имейл.
But I don't see a hand, so email me and I can forward it to Ohad. Thank you all for participating. This is really good. We have 57 people still on the call, which tells me that